in this problem, we're going to actually construct a confidence interval. But before we actually construct a confidence interval, we need to take a moment to understand the problem and to understand why the calculations that we're going to use to calculate a confidence interval are appropriate to the problem that we're solving. And so that sort of contemplation of the problem, we have this handy acronym, PANIC, for, right? So that we remember to stay calm and think carefully. So I'm actually making separate videos for each part of this acronym. This is the first one, P, parameter. But as part of this, we're also going to kind of think about the big picture of this problem. So in this story, we see that in a recent random sample of 1,750 sales transactions, 437 were in cash. And our overall goal is to construct a 99% confidence interval for the percentage of all U.S. sales transactions that are in cash. All right, so our goal in this problem is to get a confidence interval for the percent of all U.S. sales transactions that are cash. So the way that we're finding this is using a random sample. So we need to think about just what's going on in this story. We need to think about what is the population, right? What are the individuals, what is the variable, that is, what piece of information have we gotten about each individual, what is the sample, and is the variable quantitative or qualitative. We're not being asked about all of these things, but we need to understand all of these things before we can start doing anything at all in statistics. All right, so in this problem, we're interested in all U.S. sales transactions. That's our overall population. If all U.S. sales transactions are our population, well, that population is made up of individual single transactions. An individual in that population is a single transaction. Remember, an individual doesn't have to be a person. It's whatever our population is a big group of. Okay. Well, what are we asking about each individual sales transaction? What we're asking about each individual sales transaction is it cash? Right. So a sales transaction, someone goes into a store and buys something. The variable is, did they pay with cash or did they do something else? Use a card or a store account or a check? Probably usually a card these days is what you have for a non-cash transaction. And of course, that's not a number, right? We're going to get a yes or no answer. Either it's cash or it's not cash. So that's a qualitative variable. Quantitative, quantity, that's a number. Qualitative, quality, that's some property that we have to describe in words. And then our sample is the 1,750 transactions sampled. Okay, so that's kind of the big picture of what's happening in this problem. We can now think about what the parameter is. And the parameter is the property of the population we want to study. And in this case, it is the percent of all sales transactions that are in cash. The thing we want a confidence interval for, that's our parameter. The percentage of all U.S. sales transactions that are in cash is what we're trying to find. Now, that's easy to see. It's told to us in the problem. Construct a confidence interval for, and then they're going to tell us the parameter. Whatever we're constructing the confidence interval for, that's a parameter. Now, we also have to pick the symbol. And I'm going to give you a quick rundown of what all of these symbols mean. But when we're constructing confidence intervals in this class, it's all going to be something similar. All right, so these symbols, X is a random variable. It's mu. This is the population mean. It's a parameter, but it only works with a quantitative variable. We can only take the mean of numbers. Sigma, right, this O-shaped thing, that's the population standard deviation. Right. Again, that's a parameter, but we can only take the standard deviation also of something that's a number, something quantitative. There are two other things here that are parameters, and I'm going to list all the parameters first. We have a big N, that's the population size. And we have a little p, that's the population proportion. Or percentage. That's also a parameter, but we use that for qualitative data. It'll be some percentage that said yes to whatever question we're asking. We also have in this list a bunch of what are called statistics. Right? Isn't this whole unit about statistics? Yes. But also a statistic is the thing that we calculate for a sample. And we have a statistic to correspond to each parameter. Mu is the population mean. This X with a bar over it, you've seen that symbol on your calculator. This is the sample mean. That's a statistic for quantitative data. The S, you've also seen that on your calculator. That's a sample standard deviation. That's a statistic also for quantitative data. These both show up in the 1var stats on the calculator. The calculator is assuming that the data you entered is data that you actually measured, which is going to be the data from your sample. And then N is the sample size. And P is the sample proportion, or P with a hat over it. That's a statistic for qualitative data. Okay, so that's actually way more information that you need way more information than you need to answer this question, but I want to tell you what all this stuff in this menu is. For our confidence intervals, our parameter will always be P. So in this part, you'll always select P for what is the correct parameter.